Okay, so the example that we were going to work on is the integral of x times 2x plus 7 to the 8 dx, and we agreed that the that u should be 2x plus 7, and then we see that du would be 2 times dx, which gives us half du equals to dx. So in my integral, I can replace 2x plus 7 by u, so I get u to the 8. I can replace dx by half du, but then I have this x here, so what should I replace x with? So I need to write x in terms of u. Yeah, so notice that from here I get that x is equal to u minus 7, right, divided by 2. So that's what we're going to plug in here, u minus 7 divided by 2. And so what I have is a 1/4 inside the integral that can be taken outside, and I have u minus 7 times u to the 8 du, and let's multiply out now, so I get u to the 9 minus 7 u to the 8. Now we just apply the power rule, so this will be 1/4 1/10 u to the 10 minus 7 times 1/9 u to the 9 plus a c. And so what do we have? We have 1/40 u to the 10 minus 7 over what? 36 u to the 9 plus a c. And finally we replace u by, we need to replace u with 2x plus 7. Okay, is everybody okay with that? Yeah. Any questions at all on this problem? Okay. Any other questions on any other homework problems? Go down a little bit. Okay, so let's do some other example. Is everyone done with this? Okay, so let's look at another example. Let's say I have, does anyone have any other problems from the homework that you want me to go over? Any other problems in the homework? No? Okay, so let me then look at the following example. This is cosine of root x cosine of root x divided by root x dx. So that's the integral that I have. And so what should I do here? What would be your pick for u? Your pick for u would be what? Was that? Your pick for u would be? Root of x, yeah. So instead of having cosine of root of x, you want to take u to be root x. And then the differential of u would be, what's the derivative of root x? Root x is actually half, right? So the derivative of that is half x to the half minus a 1, which is half x to the negative half, which is 1 over 2 root x. Oh, I forgot to multiply with dx, right? I should be multiplying with dx. Okay, so that's what we get if for differential of u. And then what do I do? Well, the integral that I have now, I'm going to make the substitution. Actually, let's if du is 1 over 2 root x, then 2 du is what? 2 du is 1 over root x dx, right? You agree with that? So the integral that I have is cosine of root x, and then I'm going to write the root x in the denominator as 1 over root x. So I haven't changed anything, I just rewrote the integrand. Now I'll make the substitution. So this would be cosine of u, and then 1 over root x dx is what? 2 du. And because 2 is just a constant factor, take it outside of the integral. I get cosine of u du, and then the integral of cosine u is what? Sine of u. And then finally, what is u? Replace u with root of x, and that's the integral. Okay, is everyone okay with that? Any questions on that example? Any questions on that? No? Okay, so let's move on to the next problem. Let's say I have an integral that looks like 4z over 4 plus z squared to the power 3 half dz. Instead of using x, we are using z here. So how would you do this problem? Well, you take u to be what? What should I pick u? We should pick u to be, in this case, 4 plus z squared, because if you look at 4 plus z squared, if that was just z, then the problem would be much simpler, right? So let's pick u to be that and see what happens. So you take du would be what? 2 times z dz, and then I could say that half du is z dz. So let's look at our integral again. I could say that this integral is equal to, I'm going to first of all rewrite this, okay? So this is 4 over 4 plus z squared 3/2, and I'll write z dz separately. Now, making the substitution, we get what? We get 4 over u to the 3/2, and z dz becomes half du, so that I get 4 divided by 2, that's just 2, and because it's a factor, I can take it outside of the integral. And so what I have is 1 over u to the 3/2 du, right? 4 and a 2, half reduces to just 2, and then that 2 can be taken outside. Once I have this, then this is just a simple power rule. This is u to the negative 3/2 du, and the exponent is not negative 1, so I can apply the power rule. So this would be what? 1 over negative 3/2 plus 1 u to the negative 3/2 plus 1. And what is that? Well, this would be 2 times, what is 1 minus 3/2? That's a negative half here, right? And then u to the negative half plus a c. And negative half in the denominator, so that's going to be multiplied by 2. So that's going to be negative what? Negative 1 over negative half is the same as what? Negative 2, right? So I get negative 4 u to the negative half plus a c. And now I have to replace u with, I think we took u to be 4 plus z squared, so I get that to be to the negative half plus a c. And if you want, you can write that as negative 4 over 4 plus z squared to the square root, right, plus a c. Everybody is okay with that? Questions? No? Alright, so let's look at another example. Let's say I have the integral of secant squared of 1 over x divided by x squared dx. So how would you pick u in this case? What's that? Yeah, 1 over x. And that's the same as actually negative 1. So when you take the differential of u, you get negative x to the negative 2, right? Which is negative 1 over x squared dx. I forgot the dx here. So what we get then is that negative du is equal to 1 over x squared dx, right? We are multiplying both sides by -1. So that's what we get. And now we can make the substitution here. This would be equal to what then? This would be equal to, first of all, let me rewrite the integrand as secant squared of 1 over x, and then let me write 1 over x squared dx together. Is that okay? I have an x squared in the denominator, so that's 1 over x squared. And now I can make the substitution. So this would be secant squared of u, right? And then what is 1 over x squared dx? That's negative du, right? And we can take that negative outside of the integral, and I get secant squared of u du. And what's secant squared? What's the integral of secant squared? Tangent of u. And finally replace u with what? 1 over x. And that does it. Is everybody okay with that? Everybody's okay with that? Any questions on it? No? Alright, so let's look at the next example. There are problems very similar to this in your homework, okay? Let's look at another example on substitution. So let's say I have the integral of secant squared of theta times tangent cube of theta d theta. And okay, so in this case, what did you pick for u? Secant squared, you want to pick that for u? Now remember, whatever u you pick, right? Whatever u you pick, the derivative of that u must be a factor in the integrand, right? You agree with that? So in this case, would you pick, so remember this integrands that I have here, right? This is basically secant theta whole squared, right? And this is tangent of theta whole squared, right? That's what I have. Oh, sorry, cube. That's what I have. Notice that the derivative of tangent is what? Derivative of tangent is exactly secant squared. So that tells you maybe that's a better choice. So let's see what happens. If I take u to be tangent of theta, then the differential of u would be secant squared of theta d theta. And if we make the substitution now, we get what? Well, let me rewrite this first. I get tangent of theta cubed times secant squared of theta d theta. And I can replace tangent by u, and I can replace this thing here by du, and then it's just a power rule, 1/4 u to the 4 plus a c. Finally replace u with, what did we pick for u? Tangent to the 4 theta plus c. Is everybody okay with that? Everybody is okay with that? Any questions on this problem? No? Okay, so I won't do any more examples from 4.5. I think that's enough for now. And when you go over the homework problems from section 4.5, I only assigned homework on web assigned from 4.5, but I haven't assigned anything from the text, but I will be tomorrow. Again, I am also going to assign some problems from 4.4 as well, but they will not be covered in the exam, but I will be setting up 2 homeworks that will be due on Monday after you come back from the break. The reason is, I didn't want to be the evil professor that made you work during the break. On the other hand, if you want to work in the break, go over and finish up your homework, you can. Otherwise, you can finish it on Monday. Okay? But there will be 2 homeworks, one from 4.4 and one from 4.1 and 4.2 that I will be assigning on web assign. But now section 4.4, the homework that I'm going to assign are problems 5 up till 15, the odd problems. But so I want to go over a few of those so that I feel good about doing some problems from 4.4 before assigning those problems. But you'll see that essentially we have done those problems before. Okay. So section 4.4, one of the exercises, this is exercise number 6 in that section, and it is asking you to find the integral of root of x cubed plus the cube root of x squared dx. So how would you compute this integral? Well, you just express each summand as a power of x, right? So what is the root of x cubed? Root of x cubed is just x to the what? 3/2. And then cube root of x squared is just x to the 2/3. So I express them in terms of powers of x, and then I apply the power rule. So if I apply the power rule, I get 1 over 3/2 plus 1, x to the 3/2 plus 1, 1 over 2/3 plus 1, x to the 2/3 plus 1, and then I just simplify them, and if you simplify them, you get 3/2 plus a 1 would be a 5/2, and 2/3 plus a 1 would be a 5/3, and then you can write them as 2/5 x to the 5/2, 3/5 x to the 5/3 plus c. We did similar problems before, but I want to make sure that I do a few more. Any questions on that problem? Okay. The second problem that I want to do from there is this one. This is involving trig functions. So you have the integral of secant multiplied by secant plus tangent. Okay. Okay, this is what I have. Integral of secant times secant plus tangent. So how would you compute this integral? Well, there is no, you cannot say right away what's the integral is. You have a straightforward algebra that you can perform here, which is multiply out, right? So see what happens if you multiply out. So if you multiply out, you'll see that you get secant squared of t plus secant times tangent, right? You agree with that? You multiply, you get that. And then, do I know the integral of secant squared? Yes, tangent t, right? And what's the integral of secant tangent? The integral of secant tangent is secant, right? The derivative of secant is secant tangent. So the integral of secant tangent would be secant. So I have tangent t plus secant t plus c. That's the integral of that product. Is that okay? The next integral is integral of sine 2x over sine x. How would you compute that integral? How would you compute the integral of sine 2x divided by sine x? Yeah. Well, you are evaluating the sine function at the angle 2x. That's not 2 is not a factor. 2 is a factor in the angle, right? You're applying the sine function at that angle. It's like saying apply the sine function at 2 times pi over 4, which is pi over 2, right? That 2 cannot be factored out, right? So if I could, then it is just sine x over x, and then you just get 1, right? So that 2 cannot be taken out, right? Okay. What else can I do? How would you compute this integral? Was that? What did I say when we reviewed the trigonometry long time ago in the first couple of weeks? One thing I told you that whenever you have something to do with trig functions, if you have no clue what to do, what do? You apply identities, right? Trig identities. And what trig identity can I apply here? What trig identity can I apply here?
2 sine of x, cosine x.
Sine of 2x, double angle formula. Sine of 2x is 2 sine x cosine x. Okay, so you get 2 sine x cosine x as the value of sine 2x. So if you do that, now you can cancel out sine x. You'll be left with 2 times cosine x, right? So cancel out sine x at this point. You get 2 cosine x. And integral of 2 cosine x is what? 2 times sine x. So it's 2 times sine x plus c. That's the integral at the end. Is that okay? Everybody's clear? Do you have to remember the trig identities? Sure. Again, remember when we reviewed the trig functions, I told you to write down your formulas in a piece of paper and start put them on your wall, and then start looking at it every single day, and you're going to remember it. Okay. All right, so section 4.4, we have done like half of section 4.4 and half of section 4.5. Okay, and I am going to be assigning some exercises from these 2 sections tomorrow that you should be finishing by Tuesday after you come back from the break. Okay. So now what I want to do is start section 4.1 and section 4.2. And right now I'm not going to motivate you about what we are going to do now. I just want to go over certain preliminary stuff, and then I will motivate what I'm trying to do in these sections. Okay. So first of all, we need some notations. One of the important notation we need is the summation notation. Summation notation. How many of you have seen this before? Many of you should have seen it. So if I write sigma, this is the Greek letter sigma, and if I write sigma and then I write I equals to 1 up to n, and then if I write ai, this is an abbreviation of the sum a1 plus a2 plus ... plus an. Okay, So that sigma notation is used to denote sums. Okay. That is, if you have a long sum, this is an abbreviated way of expressing it. So what is AI? AI stands for a formula for the ith component. If you have a sum and the sum has n summons, right? How many summons do I have? N of them. And what is AI? AI is telling you what is the formula for the ith summon. How do you compute the ith summon? That's what's given by AI. So in the summation notation, notice that it says summation I going from 1 up to n. It tells you how many summons are there. There are n summons. Right? Instead of I going from 1 to n, if I have I going from 2 to n, then how many summons do I have? I have then n minus 1 summons, right? So right now the way we have it here, so AI represents the ith summon. So when I is 1, you get the first summoned A1. When I is 2, you get the second summoned A2. When I is 3, you get the third summoned A3, and so on. Is everybody okay with that? Anyone in computer science? No? Okay. So these type of notations are used all the time in computer science. Here's an example. Suppose that I have the sum I going from 1 up to 5, 2I plus 1. So what sum is represented by this sigma notation? What sum? Well, 2I plus 1 is a formula for computing the ith summon, okay? How many summons do I have? 5. 2I plus 1 is the formula for the ith summon, right? So when I is 1, you get the first summon. So when I is 1, what summon do I get? 3. When I is 2, I get 5. When I is 3, I get 7. When I is 4, I get 9. When I is 5, I get 11. So 2I plus 1 is telling you how to compute the ith summon. And I could be 1 up to 5. I could be 1 up to 5. Is everybody okay with that? So then this is equal to what? Is that 35? Okay. Let's look at another example. Let's say I have the sum I going from 1 up to 4, I cubed. So in this case, the ith summand is given by I cubed. So then when I is 1, I get what? 1 cubed. When I is 2, I get 2 cubed. When I is 3, I get 3 cubed. When I is 4, I get 4 cubed. And this is what? 1 plus 8 plus, what is that? 27? And what is 4 cubed? And altogether, what do I have? 100? Everybody's okay? Alright, everybody understands this notation. So when we write sum I going from 1 up to n, we mean that we have n summons, and then AI tells you how to compute the ith summand. Okay. There are two properties of this notation. So some properties of sigma. Number one, if I have the sum I going from 1 up to n of C multiplied with AI, then that's the same as C times the sum I going from 1 up to n of AI. On the left hand side, what is happening? Every summon has a factor of what? Every summon has a factor of C. So basically we are factoring that out, right? So notice that the left hand side is basically what? C times A1 plus C times A2 plus dot 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 plus C times AN, right? That's the left hand side. And what is the right hand side? Well, it is C multiplied with A1 plus A2 plus dot 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 plus AN, right? So what did we do? We just factored out that common factor C, right? Is everybody okay? Okay, so that's property number 1. What's property number 2? What's property number 2? Suppose that I have the sum I going from 1 up to n of AI plus BI, and then that's the same as sum I going from 1 up to n of AI plus the sum I going from 1 up to n of BI. What is happening here? Well, if I write it out, if I explicitly write out the sum, you'll see what's going on. What is the left-hand side? The left-hand side is basically A1 plus B1, right? That's the first summand on the left-hand side. What's the second summand on the left-hand side? A2 plus B2. And plus dot dot dot, the last summand is AN plus BN, right? You guys agree with that? What do I have on the right hand side? The right hand side is basically A1 plus A2 plus dot 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 plus AN, right? Plus the second sum is what? B1 plus B2 plus dot 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 BN. So what did we do? We just grouped together the corresponding summands, right? On the right hand side, right? How do I go from the right hand side to the left hand side? Well, on the right hand side, I'm basically grouping together the corresponding summands, right? So summand 1 from the first sequence of numbers and the summand 1 from the second sequence of numbers are grouped together as A1 plus B1, right? You see that? So this is just grouping together the summands, nothing else. Is everybody okay with that? Let's look at some examples of using this properties. Let's say I have the sum I going from 1 up to 3 I cubed plus 2I plus 1. And so let's see what that is. This is equal to, by property number 1. So if I apply the property number 1, property number 2, then I can write it as the sum of I cubed plus the sum of 2i's plus the sum of 1. And then notice that this is a sum I going from 1 up to 3 of I cubed plus this is 2 times the sum I going from 1 up to 3 of I. So now I'm applying property number 2. If I have a constant factor, I can take it outside of the sum. And here I get this. And now notice that the first sum is basically 1 cubed plus 2 cubed plus 3 cubed. The second sum is 1 plus 2 plus 3. And the third one is what? it says that you have 3 summands, and every summand is what? 1. So it's 1 plus 1 plus 1. And so here I get what? I get 36 here, is it? And what do I get here? 12. And I get a 3 there, and altogether, what is that? What is that? 51. Is everybody okay with that? Any questions? Okay. Let me end by writing some formulas. So there are some formulas that we will use later. So these are some special summation formulas. Number 1, if I take the sum I going from 1 up to n of I, that sum is basically what? 1 plus 2 plus 3 plus dot 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 plus n, right? So if I'm taking the sum of i's, I going from 1 to n, then the first summand is 1, second summand is 2, and so on. And what is that sum? Well, we have a formula for that. It says that that sum is n into n plus 1 divided by 2. Okay. Formula number 2, the summation I going from 1 up to n of I squared, which would mean that the first summand is 1 squared, the second summand is 2 squared, dot dot dot. The last summand is n squared. And it turns out that we have a formula for this sum as well. It is n times n plus 1 times 2n plus 1 divided by 6. And number 3, if I have the sum I going from 1 up till n, I cubed, that's 1 cubed plus 2 cubed plus dot 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 plus n cubed. And the formula for this sum is that it is the same as n times n plus 1 divided by 2, and then you have to square that. Is everybody okay with that? Alright, so next time we're going to use these formulas and go over some exercises, okay?